Okay, so the question asks, the figure above shows a 31.8 kilogram skier being pulled up a hill by a motorized gear. The snow that has built up on the skier's skis creates a coefficient of kinetic friction between the skis and the surface of 0.08. The skier pulled up the 29-degree hill at a constant rate of 2.6 meters per second. How much power must the motorized gear supply? Okay, so let's start off with a diagram. So, as you can see the skier being pulled up by the motorized gear, and we can find our forces from this. So it would be Ft, the tension that is the motorized gear is pulling the skier up, Fn, that is always there, always pointing perpendicular to the surface, and then Fg, that always points down, and then from the kinetic friction between the snow and the skier, that's pointing down. So let's look at this in an XY coordinate system. So as you can see, there's the XY coordinate system. This is the X right here, and this is the Y. And we have all of our forces, that pointing up, Fn, that pointing to the right, Ft, and that pointing to the left, Fk. And then we have it at the angle with Fg pointing straight down, and that angle is 29 degrees. So let's go to our given now. So for our given, we are given that the velocity of the skier being pulled up is 2.6 meters per second, and this is constant. Then we also have the angle that the slope is on, which is 29 degrees. And then we also have the coefficient of kinetic friction, which is 0.08. And then we're trying to find Fg, Fn, Fk, and Ft that will help us find what the power is. And then we also have the mass, which is 31.8 kilograms. So let's start off trying to find all of our forces. So first off, let's start with Fg. So Fg will be equal to mg, which will be 31.8 times 9.81. And if you plug that in the calculator, you'll find that Fg is equal to 311.9 newtons. So let's write that up here too. Okay, from what we just found for Fg, we can now find Fn. So Fn would equal Fg cosine of theta. So we have what Fg is now, which is 311.9. That times cosine of theta, which is our slope, which would be 29. And if we plug that in, we will find that Fn is equal to 272.84 newtons. And since we just found Fn, we can now find F of K, F of the kinetic friction. So F of the kinetic friction is Fn times the coefficient of kinetic friction. So that would be what we just found, 272.84, that times 0.08. And from that, we will find that the force of the kinetic friction is equal to 21.83 newtons. So let's write down what we have for Fn that we just found, which was 202.84 newtons, and what we just got for Fk, which is 21.83 newtons. But now the question is, how are we supposed to find Ft, which is basically the applied force? So in order to find the applied force, we would just have to do a net force equation. So for F net of y, we would find that Fn is minus Fg cosine of theta, and since it's constant, it would be equal to 0. But we can't find what Ft is from that. So now we would have to go to the x direction. So now we would find that Ft minus Fg of sine of theta, also minus F of the kinetic friction, and that is also equal to 0 because of the constant. So now we can figure out what Ft is from this. So Ft is now equal, if we add Fg sine theta and F of the kinetic friction onto this side, we'll find that Ft is equal to Fg sine of theta plus F of k. So if we plug in what we've gotten from our given, it will be Fg of sine of theta, it would be 151.21, that plus 21.83. And adding that up, we'll find that F of t is equal to 173.04 newtons. Okay, so what can we now do with F of t? From what we can get from F of t, now we can find the power. So Pt will be equal to Ft times velocity times cosine of theta. But let's not regard cosine of theta in this because it will just not work out. So it will be Ft, which we just found, which is 173.04, that times 2.6, and then we'll find that the power of T is equal to 450.0 watts. Okay, so how can we check this? So for our check, we will just be plugging in the power into the equation we just found, and it will be Pt is equal to Ft times V times cosine of theta, but let's just disregard the cosine of theta here. So we'll find that we just plug in 450.0 for power, which is equal to Ft, which we'll try to find and see if it works, times 2.6. So if we plug this in, divide 2.6 on both sides, we will find that F of t is again equal to 173.04 newtons. So we just checked our problem, so we have figured out that the power does in fact equal 450.0 watts.